Okay. Oh, awesome. Okay. Okay. Hello. Oh. I just have to be gentle. Okay. Hello, everyone. It's like testing. But hello, everyone, and thank you for coming to our 3D printing program with NASA. This program is a tie-in. If any of you have noticed the wonderful exhibit that we have out in the library lobby called Discover NASA. It's kind of an exhibit that is like an introduction to all the kind of wonderful work and research that NASA does both in space and on Earth, as well as kind of a little bit of the history of NASA. And one of the things that isn't mentioned out there, so that we wanted to have a special program for it, was the fact that NASA is using 3D printing for their research and exploration. I see a lot of kids in the audience. Do any of you guys have 3D printers at your school, or have you heard a lot about 3D printing? No? Okay, well, not yet. It's still kind of a relatively new technology, but it's showing up a lot in schools as well as your local libraries. Hopefully you'll even see one here, maybe next year or definitely in the near future. But 3D printing allows people to print solid objects from digital schematics using a special kind of plastic that melts and is extruded in layers. And NASA has been using this technology for their own research and to kind of give you an idea of how they're doing that. I have a nice little video that I wanted to show you real quick where we have a spokesperson from a company called Made in Space who has designed a specialized 3D printer for NASA to work in zero gravity or microgravity environments. Is going to talk about their product and why 3D printing in space is important. So I will play that. And then afterwards, Jamie from WallBots and Ben will also do a demonstration to go into more detail about how 3D printing works. So, and I'm not sure if they mention it in the video, but I'll just go ahead and say that this company, Made in Space, they launched their first 3D printer in last year in September 21st, 2014. So it's already currently installed on the International Space Station with astronauts and researchers are already using it to print objects for their work. And later this year, they were the one that they just printed, or the one that was sent up in 2014 was kind of the basic plastic printing model like you see back here, but later this year or early next year, they were also planning to send up a commercial one that will print even faster and also work with other materials like metal and wood, and so give the scientists up there even greater versatility with what they can print and use for their experiments. So I will, without further ado, I will go ahead and start the video.
Huntsville, Alabama, and talk with Lori Meggs. Lori, typically we wouldn't be talking about a printer heading up to the space station, but we hear that this one may be a little bit different and special.
That's right, Josh. It's not your average printer. This is a 3D printer that could be used on space station where NASA astronauts might not have to wait on resupply spacecraft to get their supplies. They may be actually able to build something right there. Joining me now is Nikki Werkheiser, and she is the 3D print project manager here at Marshall. Nikki, first of all, tell us what 3D printing is all about.
Hi, Lori. Happy to. Thank you for having me. 3D printing, a 3D printer will extrude plastic, metals, or other materials to build layer on top of layer to create a three-dimensional object. So you might be able to print all sorts of tools, spare parts, things like that.
So it kind of sounds like the Star Trek replicator, right?
Absolutely. We get that a lot, and it is the first step toward that.
Tell us how it all works.
Okay, the 3D printer that we're going to fly in space station will actually be the first ever 3D printer in space. There are tons of printers many people have heard about on the ground. As a matter of fact, my 9 and 11-year-old daughters are asking for one for Christmas. And they have them at Staples and places like that, and you can create all kinds of things with them. But the one that we're looking at for microgravity, of course, we want to build space parts. So the design optimization is very important. As we all know in space, you have to wait for, as you mentioned, the resupply ships if you need a spare part, or you have to fly a lot of spares up, which take considerable mass and which cost money. Also, things break, and things do actually get lost. We've been on space station for quite a while, and things get sucked into corners and crevices.
No.
Yes, it happens. On top of that, there are unique type of things that we could do if we had a capability to build in space. For example, CubeSats. Many people have heard about these small CubeSats, and with the onset of nanosat technologies that we have, these are used for all sorts of things in academia, commercial, and you actually can deploy them from the space station. If we were able to print these on orbit, the crew could assemble them and deploy them from station. You can do all sorts of unique structures and just an abundance of different types of experiments.
So this one was built here at Marshall?
Yeah, this one was printed here, and this is just kind of the case of one. It's got some electronics that go inside, and you deploy from station.
So how long does it take to build something like that?
Something like this would actually only probably take an hour, hour and a half. And then you also have things like this. It looks pretty non-assuming. It looks pretty simple. You could print this probably in 15 to 20 minutes. We would just upload a CAD drawing to the printer on station. But what this is actually is MSG, an extraction tool that they did not have on orbit. And actually MSG was down for around 6 months waiting on a resupply ship to bring this up. This is something with the 3D printer capability that we could have actually printed, had on orbit within 30, 45 minutes, able to go.
Wow, what else do we see here that
We've got some other just fun things. Of course, people think of crew tools and wrenches. We've got a metal one here too, and we're starting with plastics for this first printer, but we will be moving to metals and other types of materials. We've got things like, you can imagine, different size sample containers. You can also do interactive.
Oh,
sorry about that. That wouldn't happen in space. It would float away. So you have interactive parts like this that can move. You can do complex parts as well with unique structures.
So tell us about the unit that is actually going to station.
So we're working with the company Made in Space. They're actually located at Ames Research Center, and the project is led here out of Marshall Space Flight Center. It's a really good interaction between this commercial company, whose business model is to create a commercial additive manufacturing 3D printing facility on space station. This is the first step. It is a technology demonstration. We'll operate inside the microgravity science glove box. And NASA has been providing the discipline expertise and the expertise in terms of taking a printer that you would use on the ground, which Made in Space are absolute experts on that, as well as designing for space, and making sure that we can verify that for microgravity, the physics of microgravity, as well as the safety and operational constraints in the controlled environment of space station.
And this is also critical, being able to replace parts like this on orbit for future long duration.
Absolutely. The big thing about this is for space station even, it will decrease risk, decrease cost, and increase efficiency. But for longer term missions, for space exploration, this is absolutely a critical technology.
And talk about the ones that we have here on Earth. Will this technology make them better?
Absolutely. There's a lot of applications. We talked to several of our industry partners, as well as academia, even international partners on the ground here. This is an area that has exploded in the last few years. It's been being used in an abundance. So the lessons learned from the microgravity application could actually apply to things on the Earth, especially when you think of things such as maybe the Army. Maybe you have folks out in the field in a remote area, and they have the same type of problems we have in space. Things break and you're remote. You can also think of things like submarines or even just remote regions. Also commercial growth. So in this smaller size and form and function that you get from the printer, you could absolutely apply that to Earth applications.
So we've seen the video of the printer and work with that, but how big is this unit? I mean,
so this is kind of cool, and I don't know if you can see it here, but this is actually, we printed a model of the 3D printer. This first printer will be a technology demonstration, so it's a little smaller because we fit it inside of the microgravity science glove box on space station. So the crew will actually put their hands inside of the glove box to operate the experiment. We're getting a lot of materials data, and ultimately what this will demonstrate is that the objects that we print in space are equitable quality to those that we print on the ground, that there are no difference in the way that the printing takes place in the physics and the material quality. Made in Space has already done a series of parabolic flights on the KC-135, affectionately known as the Vomit Comet, and they've had excellent results. Everything has shown that it is equitable to Earth, but you get the short spurts of microgravity, and we want to be able to generate full products on orbit.
I'm sure astronauts are excited about this, so
Yes.
tell me when we'll see this on station.
And we will see this next fall and be launching on SpaceX 5, and we're actually working with the astronaut office now. We already have a set of tools and things that they've picked out and said, hey, can you provide this for us? And we're working toward that now.
Very exciting stuff. Can't wait to see it. Maybe you can build me something a little bit later on today.
Absolutely. We have a lot of fun with this. Thank you, Lori.
Nikki, so much. And let's take a live look into the Payload Operations Integration Center. Busy at work today, setting up some experiments. SLAM-D, they're working with the crew on station today.
Okay, I'll go ahead and pause that. So that was one of actually quite a few videos that is on the NASA website. If you just Google 3D printing NASA, you can actually see a few other videos that explain about what they're doing with 3D printing, as well as you can also look up the company Made in Space, where they also talk about the printer directly. In the back that you can, on that table over there, I have a little handout that kind of, again, discusses what was just mentioned in this video. But at the end of that, there is also mentioning of a 3D printing contest or design engineering contest for kids grades kindergarten through 12th grade. But it's a design contest sponsored by NASA where you can enter in 3D printer designs and for astronauts to be used in space. And it's an ongoing contest. There's a website address for it if you guys are interested. So, but with that, I will actually now hand it off to Jamie and Ben, who will discuss in detail about how 3D printing works.
You hear me? Okay. So welcome. Thanks for coming today. I'm going to quickly get through a longer format presentation that we do about introduction to 3D printing. And we'll talk about some of the concepts. My name is Jamie. I'm with IT Works. We are a authorized reseller of WallBots 3D printers. How many of you watch How It's Made on the Science Channel? Yeah? All right. You seen the segment on 3D printers? So WallBots are made here in Colorado, in Loveland. That segment on 3D printers was filmed at WallBots. So where these printers are made is just about 45 minutes north in Loveland. They have tours every Friday at 2. It's really a cool tour. If you've ever watched How It's Made and said, man, I wish I could go there, you can with WallBots. Just show up at 2 o'clock on Fridays and go see how they're made. Really a neat place. They have a room with 150 3D printers printing parts to make more printers. The one on the right has about 40 printed parts on it. The one on the left has about 25 printed parts. And they're an open source company, meaning that everything about those printers is freely available. They share. They let you modify them, make your own replacement parts. Really great printers. And as a authorized reseller, IT Works does training, support, sessions like this. So if you have a school, another organization that's interested in printers, we help make them a useful tool around here. So I'm going to quickly go through a presentation. It usually takes a little longer. I'm going to show you guys some 3D modeling skills, which is the important part as well. When I start in, I like to give you a basic introduction. If you've never seen a 3D printer before, give you enough information that you'd be comfortable sitting down with one of these printers and doing something with them. And a lot of things we're going to talk about apply to other 3D printers. So I like to say that a 3D printer is a machine that takes a digital file, like a CAD model, and a roll of filament and turns it into a physical object. There's several different types of printers. The first one on the list is what's referred to as an SLA printer. 3D printing's actually been around for about 30 years. The first technology was SLA, where you take a liquid resin and you apply UV light to it to harden it in certain places. 3D printing's been around for a long time, but there were a bunch of patents that tied up some of the core technologies until about 5 years ago. And that's why you've seen a real explosion in 3D printing tech in the last 4 or 5 years. The secrets have been locked up. And Another type of technology for printing is what are called sintering printers. When NASA was talking about printing with metal, that's what you usually do. You have a metal powder or a plastic powder that's fused together with heat, often with a laser. There's also printers that start with powder and fuse them together with adhesives. And then the tech we're going to talk about primarily today is what you saw in the NASA video, fused filament fabrication or fused deposition modeling, basically where you take a filament of plastic, feed it into the print head. In this case, we're starting with a filament that's 3 millimeters, and then we're squeezing it through a nozzle, what's called extrusion, down to a 0.5 millimeter, just like a hot glue gun, basically. They're like robot hot glue guns, more or less. And that's the most common, that's the least expensive printing technology that's out there, and the most accessible for home, small business, and education uses. And then I like to say that 3D printers aren't quite yet an appliance. There's a lot of skills with them that's kind of like learning to play an instrument. You know, you can pluck away at a guitar or start playing to the piano, and as you practice with it, you get better and build the skills. So questions on the tech itself? Okay. So I like to talk about safety a little bit. As you're dealing with these, you do have the part that's melting the plastics, usually between 400 and 600 degrees. So that can burn you instantly. The beds on the printers are up to 200 degrees. Some printers don't have heated beds, but all of these use heated nozzles. So you have to be careful about burns. There are many materials that require a heated bed to adhere to the bed. Getting the materials to stick in the first place, a heated bed opens up to a much broader range of filaments. The WallBots are all heated beds, and these two models can print all but the most exotic filaments. Other printers limit you to a narrower range of materials. If you're sensitive to petroleum fumes, there are plastics that are starch-based that are more pleasant for that. So that's something to be aware of. If you are, you might want to pick a filament that you're okay with. And then you have to watch for pinches as you see things moving around. I won't point out all those details, but there are a few pinch points. There's also entanglement points. There's moving motors and belts, so you just need to be careful of loose clothing, hair, things like that. And then fire, the hot ends are hot. I've not seen a fire from them, but it is possible, so just be careful of that. And then the major danger with them is cutting yourself. The knives that we use to pop things off the bed are sharp enough. I've hurt myself more after the printer's done printing than with the printer itself. I probably burned myself more times, but voice of experience. Most of these safety tips are things I've done myself. So questions on safety? All right. Yeah.
When I saw the NASA thing, I wondered about printing in zero gravity or microgravity, and I imagine the heated bed would allow the adhesion for the plastic to stick to that bed.
Yeah.
Simulate gravity in a sense.
Yeah, there's the 3D printers. All that NASA's done with that 3D printer is just make one of these rugged enough to withstand the G-forces of space flight. There's no tech that's in there that's anything more than a ruggedized version of one of these. With probably a commensurate price tag. So we'll talk about making 3D models. Creating 3D models is actually really the important skill. A 3D printer is a wonderful tool to be able to get a physical object that started out in your mind, and 3D modeling is the really important tool to do that. The skill that you get a 3D printer as an engagement tool to get yourself, your family, your kids creating 3D models. I was going to do a quick demo of making models in a program called Tinkercad. When we do this presentation in a smaller training session, we'll often have people sitting at stations and walk through with us, but I'll show you some of the steps. I was going to point out too, this right here is something that my son made yesterday. He wanted to make a baseball bat holder. My son's 10, by the way, so he sat down at a computer and designed this thing yesterday. And I was going to suggest a couple of changes to him, maybe a little indent right here for the screw head to sit flush, but I think he did a really good job, and I'm looking forward to printing this tomorrow when we get a chance. So Tinkercad is a website, tinkercad.com. It's free. You can sign in with your Facebook account, and then all of your models are saved to the cloud. So you can work on one computer, close out there, do something at the library, work on a model, and take it home. So I'll show you how easy it is to use. I'm just going to click on Create New Design. And there are arrows for panning and tilting the bed here to change the angle of what you're viewing. You can zoom in and out with the navigation here. But the easier way to do that is with the mouse buttons. If I click and hold the right mouse button, I can get my tilt and my pan this way. If I scroll in with the mouse button, I can zoom in, and scroll out, I can zoom out. If this seems pretty cool, they have computers here. You could just walk out of here and start doing some of this modeling. And there's a tutorial that comes with Tinkercad, but I'll show you all the steps I'll make something that show you all the important steps so you get an idea of some of the tools that you have to use. The other thing I can do is if I hold down the scroll wheel, push down on it, that lets me move around the bed like this. There's a couple of other things. This name up here is automatically created by Tinkercad. If you want to change that, you go up to the Design menu. I'll show you a couple of things in Design. New would make a new model. It would close what I'm doing and make a new model. Duplicate's pretty handy. If, say, you got a model the way you like it and you want to make some changes to it, you make a duplicate of it, and then you can make the changes to the new one while keeping the other one how you had it. Save tells Tinkercad to save it. Normally it saves automatically as you're working. And then properties, I'll get back to in just a second. A couple of other things, download for 3D printing would allow you to save the model to then put into the 3D printing software. And then download to Minecraft. How many of you play Minecraft? Kids? Yeah, hands. So if you ever want to make something that can go into Minecraft, Tinkercad will let you make models to go into Minecraft. So now you're all going to run out and go Tinkercad now, right? Yeah. Okay. And then upload to Thingiverse also. Thingiverse is a website that has a lot of different models. It allows you to send the model straight to Thingiverse. So I'm going to go back to Properties. If I click on Properties, I have a name up here, and we'll just, Louisville Library. Spelled Louisville right? And then you can make by default the model is private, meaning no one else can save it, but you can also make the model public. And that means that other people can find your model and make their own copy of it and download it. And below that, you have options for the license. You can say anyone can do anything they want with this model if you've made it public, or you can say anyone can do anything they want as long as they don't sell it. You can print your own, but you can't sell it, a non-commercial license. And this explains the licenses here. I'll change this back to private for now, and I'll say Save Changes. And you see now, I've changed the name of it. And the little circle that you see right there was it saving. So any questions so far? Okay, so on the right side, you have a bar with a whole bunch of things. This import allows you to bring in another file, JPEGs, 2D models, other 3D models. So say there's a 3D model someone else made and you want to make some changes to it, you could import that 3D model file into Tinkercad and then manipulate it and make the changes you want. Pictures, we have some, I'll talk about everything on the table when I'm done here, but you can scroll down through and there's a whole bunch of different things, a text tool, rulers, and those are all accessed through these sections at the top here. So Tinkercad works by taking geometric primitives and putting them together and adding and subtracting them to get what you want. So I'm going to make like a luggage tag today. I'm going to start by clicking and holding the left mouse button on this box, and you drag it out here, and now I have my three-dimensional box. And if you see these boxes here, these are what are called handles. If you move to a handle at a corner, it lets you resize it in two different directions at the same time. If I grab a handle on the side here, lets me resize it in just one direction. And those one directions are pretty handy because if I want to make this 30 by 60 millimeters, well, maybe I'll get 30 here, now I move it to 60, see now it's not 30 anymore. So sometimes it's handy to just grab one and move it to the one size you want, and then grab the other handle and move it to the other size. Now, that would be a pretty thick name tag, right? So I'm going to reduce it in size. I'm going to go to the top here and grab this handle, shrink it down to 3 millimeters is a good thickness for a name plate, name tag. And I clicked off of there because to deselect it to get rid of the handles, if I click on it, it selects it and brings the handles back. So start with a plate there. Not a very exciting name tag. Let's add some rounded ends to it. You can grab the cylinder here, and I'll drag it out here. Now, I want to make this the same 30 millimeters that the other one was. And I can grab this handle in the corner and resize it in both directions. But I want to make it resized the same way in both directions. So I'm going to hold down the Shift key while I'm doing that. And now I've resized it to be 30 millimeters. And then I can grab the top, drag it down to 3 millimeters, and then bring it over here. And sometimes it's kind of hard to align things with the mouse. If you want to make a small adjustment, you can use the arrow keys on the keyboard and nudge it around, in this case 1 millimeter at a time. And that setting is controlled down here. The snap grid, I can tell it to do 1/10 of a millimeter, 1 millimeter, 2, 5, a half millimeter. 1's good for what we're doing here. Now I add a rounded end to the other end. Now I could grab another cylinder and resize it, but there's an easier way. I can copy it, so Control C, and then paste, Control V, just like in a word processor. And that makes a duplicate. You can also get up here and do edit and do copy, edit, paste as well. And I can bring this over here, and I want to elongate this one a little bit. So I'm going to grab this side and I'll stretch it. So maybe you want an ellipse, this way. And now I'll nudge it back over into place where I want it. And so now we have something that's starting to look like a luggage tag. Now I can join all of these pieces together. I'm going to drag a selection box around them. So I'm clicking and holding the left mouse button, making a selection box, and releasing it, and that selects all of these things. Now I can go up here and I can use a new tool, grouping. If I click group, it puts all of those together into one object. So it gives you a nice name tag there. Now we'll put some letters on it. I can scroll down here and grab letters. L, O, U. There's another way to do this, I'll show you in a second, but there's a reason that I'm grabbing all these individual letters. All right, so I'll get them roughly lined up. So you can see this is all really pretty straightforward to do. And there's tutorials that'll walk you through all of these skills that I've shown you, but this gives you all this. Okay, now I want to line these all up on a line. I'm going to go up to the top here. I'm going to grab a ruler and bring it down. And see this number right here gives me how high it is from this line. I can go in here and change this number to 0, and it snaps each of these letters onto that ruler. So it's a nice way to line things up. I should have just done library, right? Would have been faster. So is this pretty cool? Is this something that you want to go and try at home now? Learn some modeling? Because the real power is being able to have something in your mind and then be able to make that physical object out of it. Become a creator instead of a consumer. Or, customize things for yourself. My son that did the baseball bat holder wanted to make another thing at one point, and one of the real powers in that is he made a design, and I could tell that it wasn't right when he created it. But I didn't tell him that. I just printed it out, and then he had the physical object looked fine on the screen, but he had that physical object that he could then take and go, oh, well, that's not quite right, and he went back and it took about 4 versions for him to get the thing that he wanted finally. But the real power is having that physical object that you can see, oh, this doesn't fit, or I'd rather it was this shape, or it needs to be thicker or thinner. So, all right, I'm going to get rid of my ruler here. And that's close enough. So now I can select all of these, and I could group them together like that, but I don't want to group them right now. I'm going to ungroup them. So there's the ungroup tool. And I mentioned there's another way to do text. You can grab text here, and you get a new pop-up, and it lets me do. And this one's handy because you can then go up here and change your font if you want, a different font. So that's a handy way to get a lot of text on there, but the reason I did the individual letters is what you can't do with that other tool, the text tool, is some other manipulation of these letters. So I'm going to zoom way in. Again, remember I'm using the scroll wheel to zoom. And I'm going to tilt it a little bit. Now there's some extra handles that we haven't used on here yet. There's this triangular shape, or this conical shaped one here, and then these arc handles here. These arc handles let you rotate an object around the 3 axes. If I grab this and start rotating, see how it's snapping to 22.5 degrees? That's happening because my mouse pointer is inside the circle. If I move the mouse pointer outside of it, it changes to a 1 degree snap. So that's rotating around the y-axis. If I go over here, I can grab this tool here and rotate around the x-axis. And let's go to this one, and now I can rotate around the z-axis. So you can have a little fun with your letters. Just some happy little letters. No. Too obscure, kids? No? Anyway. All right. So now that's too big to fit on the name tag. So I can do a selection box around them. Notice I haven't grouped them, but I could then go and shrink them and stretch them. Or I could resize the whole thing. You know, I could hold down the shift key and it would resize all 3 of them. And I'll bring it over my nameplate here and need to resize it a little more. All right, close enough. Now that conic handle allows you to move things in the z-axis up and down. If I want to move it in x and y, I just click and hold on it and move the mouse button. Moving it in z lets me move things up and down. And you see how it'll start to inset into the plate here. And so that would, you can see I'm just looking for, like that gap right there, that would probably be a little tough for printing. So I want to make sure it's all nice and flush with the plate there. There's a couple other things we can do. This is a luggage tag, right? So we'd want a place to run a cord through it. You can do that by making holes. And that's right here. I'm going to grab a cylinder hole and drag it out here. And I'm going to make it 8 millimeters. Again, I'm going to hold shift before I click on it. Or you could elongate it. You know, you could make it wider one direction than the other. And I'm going to drag that over here. And I'm just going to make sure that it's at least flush with the bottom. And now watch this. If I do a selection box again around these 2 objects, and you notice I don't have to get the whole, the entire hole. I shouldn't say the whole hole. That would be confusing. But I did a selection box around those 2 objects. If I go up here and group it, it now grouped that hole into this object. Now the other thing you can do, I'm going to move this plate out of the way, is you can turn any object into a hole. I can grab my letters here and I can make them right in here in the inspector. I can make them a hole. And I could drag that back into the nameplate here, group all of these, and that would give me a engraved look instead of an embossed letter there. And I didn't really want to do that, so I'm going to click undo. And one more undo to turn it back into letters. Move them back here. And if I wanted to, you wouldn't have to do this for printing, but I'm going to go ahead and group them. Them being all the same color indicates that they're grouped. One other thing, if you were doing this project, when you're printing, you want to make sure that nothing's sticking out the bottom so it sits nice and flat on the print bed. If I had any of those, if I ungrouped them and I grabbed those letters and I had anything sticking out like this, I'd probably want to use another box hole and shear that off so it's nice and flat. Because anything sticking down, the printer would start trying to print and that would print up in the air. And you want to have a nice flat surface for the printer to start with in a lot of cases. So questions on that with modeling? Was that cool, kids? Something you want to? All right. And that's, again, this website's free. And it's something that you could do here at the library, start on a project, and then head home. Hopefully they'll have some classes on Tinkercad at some point here soon too, but it's just that easy. And you can create your own free account. So that's modeling, model creation. From there, I would just do design, download for 3D printing, and you want to usually select an STL file. That's most common. If the library had a laser cutter instead of a 3D printer, you can also download an SVG file, which is a file that a laser cutter could use to cut out a two-dimensional object. I've actually made a quadcopter chassis that's designed to be made out of laser cut foam board, and I modeled it in Tinkercad to make sure everything fit right, and then I make SVG files for the laser cutter to cut out. So a couple of other uses there. So any questions on that? Or we talk about more printing stuff? Okay, so getting back to the presentation. So I guess I asked for questions. So now we'll talk a bit about the software used to actually run the printer, what I did to make these printers run. And then after that, we'll kind of come over here and we'll talk about the things on the desk. We've got some giveaways, and you can see the wrenches that they have printed at the ISS. I have some for you. So WallBots, again, is open source, including the software that runs this. That means that you can install the software on any computer that you want. If you go to wallbot.com/Cura, you can download for PC, Mac, and Linux, and their manuals, all of that are there. What Cura does is it takes the model file that we've created in our 3D model software, and then it allows you to arrange the model on the bed, and then it takes that 3D model and it slices it. 3D printers work by building the model up one layer at a time. So the software has to cut it into those layers for the printer to print. And then printer management, telling the printer to start printing, to move the head around and the bed around, to heat up, cool down, all of that. That's what Cura does for us. So it looks like this. You get the bed layout here that represents a printer bed, and it's sized to accurately represent what you can fit on the bed. On the left side, you'll see that you can change your printer. We have two different printers here, the Mini and the Taz. Since they have different size beds and build capacities, you'd want to choose the right printer for what you're doing, because it has to slice the file for the right printer. This talks about adding another machine. Don't need to worry about that. So then you load your model file. This is where you pick out your STL file, in this case. We'd do hearts here. This is the logo for Loveland Creatorspace. I'm one of the founders of the Makerspace in Loveland. Broomfield actually has, you know about makerspaces? Anyone? Nonprofit community workshops, shared resources like 3D printers and laser cutters and stuff like that. Broomfield and Westminster are just getting makerspaces open now. Da Vinci Makers at the Da Vinci Institute in Westminster and Gizmo Dojo will be opening soon in Broomfield. They just had a successful Kickstarter. That's where I'm going tonight. It's their Kickstarter party. But if you want more info about that, I can give you info about that. So anyway, here's our 3D model, the logo for Loveland Creatorspace. And you can click on it to select it, which changes colors. And just like with the modeling software, when you've clicked on it, you can drag it around the bed. Now, if you drag it outside of the print area, it'll turn gray. So we can put it back there. In the lower left, you see, there's a rotate field that allows me to click on those three rings that you see around it and rotate it in X, Y, and Z. And then you can just click lay flat to put it flat back on the bed again. If you have a model that's tilted just a little bit, it'll be kind of hard to print. The printers have a tough time with any angle over about 45 degrees. You either have to minimize that or you do what's called support material, where it prints, in addition to your model, it prints more stuff below it to support it. So we want it flat. The next box over lets you scale it up and down, so you can make it max size. We'll scale it to as big as the printer bed can handle, or you can go in there and you can type in the size in millimeters in one of the dimensions to force it. You know, you say, I want it to be 4 inches tall. Well, you could go size Z to 102 millimeters, I think is 4 inches, as an example, and it would scale them all together. There's also a lock at the bottom that you could unlock, where if you change one scale, it doesn't scale the others, but uniform scaling's usually the most handy thing. And then 0.5 would get me back to half size. And then resets it back to 0. You can also mirror it. There's some view modes that allow you to change the view. This is what's called layers mode, where it lets you scroll through the layers. It shows you what the printer's actually going to print. So, and then I'm going to skip the controlling printer motion. Basically, what I've done with these printers is I've clicked Control. I open up the printer management window, and then it's connected up to it. There's arrows for moving the carriage around, moving the print head and the carriage, and moving the carriage up and down. And then extruding, filament, homing it. There's advanced settings, which I will save you from. There's other setting. Okay, and then starting the print with the mini on the right, on the left here, you just click print. And the mini will home itself, so the printer doesn't know where the print head or bed is by default. So when you click print on them, the first thing they do is home themselves. And that means that it's going to move the carriage to the left to touch a switch. On the mini, it moves the carriage all the way up to touch a switch, and the bed all the way back to touch a switch. And from there, there's a controller that controls the motor that tells it how much it's moved away from those switches, so that it knows where it's at. The printer won't usually let itself be moved unless it's been homed and it knows where it's at. It then heats up the nozzle, cleans the nozzle, touches each of the four corners of the bed, and then heats itself up all the way and starts printing. So when it starts printing, you want to make sure that things are sticking to the bed right, well, so that it doesn't pop off the bed, and try not to leave the printers unattended. So questions on the printing process there? We'll move on to stand up and we'll show you stuff here in a minute. Oh yeah, so the filament is extruded a 0.5 millimeter tube at a time. And you actually want to make sure that the nozzle's less than a 0.5 millimeter from the bed, so that it's flattening the filament a little bit. It kind of makes an oval that's being pushed into the bed so that it's going to stick adequately. We refer to as squishing. Once the print's done, it cools off the printer, and you let the print cool for a little bit, and then you can pop it off the bed. The printers that we have here today, the mini on the left is will print objects that are 6 inches by 6 inches by 6.2 inches. They have a 0.5 millimeter nozzle. The nozzle size defines how thin the layers of the object are. The thinner the layer is, the finer, the higher the quality is, but the slower the printer will print, because it's got to print more layers to make an object. And it usually has to print slower with a thinner layer. They use 3 millimeter filament, and you connect them via USB to a computer. There's 3 millimeter filament, and there's 1.75 millimeter filament. You just get what your printer needs. The one on the right is a TAS that has a bigger print volume, 12 inches by 11 inches by 10 inches. And that one can print from an SD card. It doesn't need to be connected to a computer. It also has optional print heads for printing multiple materials as well. You can print 2 filaments at the same time. So a flexible filament and a firm filament, or 2 different color filaments for 2-color printing. And I'll just kind of go through the parts, power switches. And let's see, I was going to get to filaments real quick. So I'm going to go through least useful to most useful. Polycarbonate's an exotic, neat filament. You can print all these on the WallBots. PVA is kind of like a wood glue material, great for use for support. Laywood is like composite decking. It actually smells like wood when it's printing. We have some samples over there. Nylon, kind of an exotic, kind of hard to print, hard to get to stick to the bed. Laybrick is like a mineral-filled plastic. There's PET materials also, like plastic bottles. We have some PET material that's actually made out of recycled bottles that we're testing. And then NinjaFlex is a pretty neat one. We have some samples over there. It's a thermoplastic urethane, very flexible, very tough. And then the 3 most common ones you'll run across on a printer are PLA, which is one of the starch-based ones, inexpensive, non-toxic, and good and durable, and sticks to itself really well. Not very good with heat, though. You don't want to leave it in a hot car. High-impact polystyrene, which is the green one that's being printed on the right here. Inexpensive material, good for most model printing. And then ABS is the one on the left, which is tougher than high-impact polystyrene, a little more expensive. And then there's some other exotics that we have on the table. Yeah, the WallBots website has all of them, and you're welcome to a copy of the presentation. Happy to send that to you as well. And it's by no means comprehensive. There's more filaments on WallBots website. These are just kind of the most common ones you deal with. And I'll skip over most of the maintenance items, because I'm sure you all want to get up and we'll talk about what's going on over here and get some hands on the stuff. That's leveling the bed, removing from there. Okay, so a couple of other things then. How to get models. Create your own, of course. We've talked about Tinkercad already. SketchUp, which is made by Trimble in Westminster, is another great free option for their basic one. 123D Design, which is an Autodesk product. And Autodesk just came out with AutoCAD 360. It's either Autodesk 360. I'm almost certain it's AutoCAD 360. It's web-based also and free. It's like a more powerful version of Tinkercad. And frankly, Tinkercad's a great way to get started, but it does have its limits. Now, that said, probably 80% of the stuff I do is in Tinkercad because it's just so useful and easy to get things done in. But learning a tool with more capability like 123D, SketchUp, or Autodesk, AutoCAD 360 is probably a good idea. If you like open source, there's FreeCAD and Blender, which are both freely installable and downloadable and quite powerful, or SolidWorks. If you knew you're going to be going into engineering, starting learning SolidWorks is a good idea. Anything that creates an STL, BAE, OBJ files are the most common ones. So, questions on modeling software options? You can also download models others have shared. I showed you in Tinkercad that you can upload things to the website. Thingiverse is by far the largest selection of model files. I'll give you a tip. If you're going to download a file to print, look for a picture that someone has taken of a printed model. That means that someone was able to print it. There are ways to make models where they're not printable, and so look for a photo. It means someone got it done. And then some things to consider about when you're going to print something. Is it too big to fit on the bed? If it is, you print it in parts and assemble it. That ukulele we have over there could be printed on the Mini, actually was printed on the Mini because it's got herringbone joints in it to stick it together. So that's a strategy for something that's too big to print. And then think about how it's oriented if it needs to be supported. I use the example of a statue. If you print a statue, if it was me, just standing here, my feet don't have very much surface area to stick to the bed. So as a print head comes by trying to print, it's kind of dragging on the statue and might probably snap the feet off the bed, and then it'd flop over and it would be printing in midair, making a big mess. Or art, it's not a failed print, it's art, right? But something like a statue, you may want to take it and lay it on its back. That top surface is going to have really good detail anyway, so that would give you better print quality. And then just think about, are the walls of this too small to print effectively, things like that. You have to have some substance to it for the printer. Anything below 1 millimeter can get a little dicey if it needs to bear weight. So, any other questions on that? No? All right, so you've all been sitting long enough. If you want to come on over here and we'll talk about stuff on the table. First thing, freebies. On the left side, we have a bunch of vases, and then the white wrenches. Those are the wrenches that NASA created for the ISS, and we printed out. Those wrenches and vases are free giveaways. You're welcome to take one with you. Preferably kind of one per family. You notice that they're ratcheting. They have a ratcheting mechanism inside that keeps them from spinning. They'll only spin one direction. If you want to see how that's done, you can see these wrenches are being printed on the printer here, and you can see the inside of the ratcheting mechanisms. There's, on the end there also, we have samples of different filaments. We have several different prints. And then on this end, we have some information about the printers, our cards, and info about our company. No, that's actually designed as a structure. This is all as it's designed to be. So this is a good example to see some of the prints. And then a few objects I'll point out here on the end that you might find pretty interesting. This robot here, and these models are all hands-on. Feel free to grab them. Again, the vases and the wrenches are giveaways. The rest of the stuff are samples we like to hang on to. That robot and this elephant are printed as one piece. See how the parts move? Those weren't assembled. They printed out like that. Or this chainmail here, these chain links all interlink, you can see. Or these chain links here. And then some of these materials, this is that flexible one, and there's the Ninja Flex here. The sandal is flexible material. And then the last thing that's pretty neat, 3D printed selfies. These printers, that Cura software I showed you, instead of opening a 3D model, you can open a JPEG. This is LaRonda, one of the news anchors on Channel 9. We had a thing about 3D printing so for the Maker Faire, and so did one of these really quick. So any other questions? All right, I figured. Huh? Yeah, so you open the JPEG and the software asks you how high you want it to be and whether lighter is higher or darker is higher. And then there's smoothing also. I could show you it in action on this machine. But yeah, and then it kind of makes its best guess. Yeah. Anyhow, yeah, we purposely left quite a bit of time so that we could do questions and see hands-on and all of this here. So, but you can see the layers that are being added. You can see the tops of the wrench. And you can see the ratcheting mechanism being printed in here. Yeah. So, yeah, open source means that it's designed and licensed to be freely shareable and installed anywhere you want. WallBots actually open source hardware. They make everything about these printers freely available. All the parts, all the design specs. This gear in here, this gear here, that's printed, these are all printed. When you get this printer, they give you the files to print your own replacement parts. This gear wears out, you can print a replacement. Not only American made, repairable. What else can you get that's American made and repairable? So, but again, tours of WallBots every Friday at 2 as well. Cool place to go check out. It's like, go see how it's made. Yeah, yes. The practical application that it's freely available. It means you can install it as many times as you want, anywhere, don't have to pay anyone for it. Typically community developed, but the practical upshot is yes, yes. So open source, the terms actually mean that the source code that makes it up is open